In this video, we will learn that how to find square root of a complex number using a famous Moivre theorem. I might be saying it incorrectly, but I think it is Moivre theorem. The theorem says that if I have a complex number z is equals to r cos theta plus iota r sin theta, then I can calculate any power of that number, let's say zn, as r raised to power n cos n theta plus iota r raised to power n sin n theta. So square root of a complex number will be equals to square root of r cos theta over 2 plus iota square root of r sin theta over 2. Although in this video we are calculating square root, but we can use this result to compute any power of a complex number. So now let's find the square root of this number using this theorem. So solution. First I have to find r, which will be equals to, let's say number is z, so it will be equals to modulus of z, which is equals to 7 square plus 6 times square root of 2 whole square and then square root of the whole thing, and that will be equals to 49 plus 36 times 2 will be equals to 72, and that will be equals to 2 plus 9 is 1, and then 1 carries, and 7 plus 4 is 11, so 121, and that will be equals to 11. I have found my r. Now I have to find my theta or argument, and first I have to be careful that if my argument is in first quadrant or second quadrant or third quadrant, because depending upon which quadrant my argument is, I have to use slightly different formula, and we have discussed it already in a video. But in this case, because x and y both are positive, so my position vector is in the first quadrant. Therefore, my theta will be equals to tan inverse 6 times square root of 2 divided by 7, because it is theta in this case equals to tan inverse y over x. My y is this and my x is this, and based on my calculations it must be equals to 0.88 radians. So I have my theta. Now I can use this formula. So this, according to this formula, my square root will be equals to square root of r, so square root of 11 cos, and here I will have 0.88 over 2 plus iota square root of 11 sine 0.88 over 2, and if we solve it, then my result will be equals to 3 plus iota square root of 2, and that was my result in the last example also. So I have found my one square root of complex number. So I'm able to find one square root of my complex number, but there is another square root of this complex number that I can find by adding 2 pi in my theta. So second square root will be that I say square root of z will be equals to square root of 11 cos, and then in angle I add 2 pi, so it will be 0.88 plus 2 pi over 2 plus iota square root of 11 sine. Similarly, in the sine also I will add 0.88 plus 2 pi over 2. And when I solve this, then I will get my second result, which will be equals to minus iota square root of 2. And that is my second square root of 2. So I think using this theorem, we can find square root quite quickly as compared to the result that we have seen in the last video. So tell me in the comments which method you like more. See you in the next video.